Hello everyone, welcome to this workshop. This workshop is going to be quite interesting. We'll be working using Arduino boards, and even if you have no prior experience with working with Arduinos, you can still follow it. And in this project, I will be showing you how to make a smart bin, a bin at which you point an object and the bin automatically opens up. Right? Why do we need this project? Obviously, COVID-19, it has increased the demands for contactless facilities, and the smart bin capitalizes on technologies that are quite easily available. Of course, bin with foot pedals get the job done, but they're inconvenient when it comes to people who are actually confined to wheelchairs. So, hence the need for this project. First of all, let me introduce you to the assembly. The assembly is a smart lab based out of In5 in Dubai. Since December 2014, we have conducted over 300 free workshops. The workshops are divided into three main categories. The hack workshops focus on embedded systems, IoTs, hardware such as Raspberry Pis, Arduinos. The code workshops are for software projects, so we can learn how to use APIs, frameworks, and make applications. Thirdly, we have workshops for data science involving topics like artificial intelligence and machine learning. Our target audiences are students, professionals, and entrepreneurs, but our workshops are available for everyone who is interested in these fields. Our workshops focus on smart technologies and practical applications. For more information, feel free to visit our forum on members.theassembly.ae. Also, you can follow us on social media at MakeSmartThings on Facebook, Twitter, and Instagram, and The Assembly on YouTube. Starting with the project itself, in this project, again, I will be showing you how to make a smart bin that will automatically open up once it detects an object. Again, coming back to why we actually need this project, here is your average bin today. As you can see, while these bins are actually getting the job done, they are completely inconvenient once you consider that we are living in COVID times and the need for contactless bins is actually there. Similarly, how do you expect someone in a wheelchair to actually use these bins? Pedal bins, for example. Someone in a wheelchair actually has to open the paddle using his... Again, it's completely inconvenient, and hence there's a need for smart bins, something that will automatically open up without a physical contact. Like I said, the concept behind this bin, the main concept is object detection. The ultrasonic sensor will be placed outside the bin, and once the sensor actually detects an object like a human hand or a piece of item, it will trigger Arduino to open the lid. We'll be going about this project in a few steps. Let's look at the requirements first. The first requirement being the Arduino board and the wires. Secondly, the ultrasonic sensor, the servo motor. Lastly, of course, the bin. This is the reference table we'll be using for the ultrasonic and the Arduino setup, and this is the setup that we'll be using for the servo motor and the Arduino. The wiring itself is quite easy to follow, and once we start doing it, it should not take long for us to actually figure it out. Regarding the power supply, in an ideal scenario, you can use a 9-volt battery and connect it using a plug, or you can use a USB cable and power the Arduino using your laptop itself. For testing purposes, obviously, this is the setup map we can follow. It's a basic setup map that shows how we'll be connecting the servo and the ultrasonic sensor to the Arduino board. Once we are done uploading the code, we'll attach the items to the bin itself, and our goal here is to ensure that all the components are placed in such a way that they do not come in contact with anything, with the trash or anything else. In best case scenario, you can't see them at all once the bin opens or closes. So they should be placed in such a way that the main functionality of the bin itself is not affected. Looking at the future scope of this project, machine learning allows item detection and differentiation. A camera can now be trained to actually differentiate between objects such as glass, plastic, etc., etc. And since the camera can now differentiate between objects, the bin can be programmed in such a way that it can open up for selective objects and not open up for something else. Alright, moving on to the physical setup. First of all, these are the components that we'll be using. The ultrasonic sensor, the servo motor, the jumper cables, and of course the Arduino itself. right? So following our map, the map for our circuit, we'll be connecting the ultrasonic sensor first. So first, you plug in the VCC. So we plug in 4 pins inside, and we make sure that the VCC, trig, and echo and the GND are connected. Now on the Arduino board, we connect the VCC to our 5.5 volt. To our 5 volt actually, we connect it to our 5 volt. Then we connect the trig to number 9. Connect the trig to number 9. We connect the echo to number 8. And we'll connect the GND to the GND on the Arduino board. Right? So that's it for the ultrasonic sensor. Next we'll move on to the server. Right. All right, and for the servo, what we need to so for the servo we have 3 cables. This is the orange one, this is the orange one, the red one, and the brown one. So you can use whatever color you want. I'm going to use whatever I have over here. So you connected 3 cables. You connected 3 cables to your servo motor, and now all we need to do is connect them to the corresponding points on the Arduino board. So the orange one goes to number 7. The red one, the center one over here, this one's going to go to 3.3 volt. This is going to power the servo motor. And the last one, the brown one, we're going to send the brown one to GND as well. So we have 2 ports for GND on the Arduino board, and yeah, that's it for the servo as well. The next step is to upload the code to the Arduino board. The code will be available on our GitHub as well, and you can follow along. We'll be providing code to the Arduino board next. Moving on to the actual coding now. First, we need to ensure that the correct board is selected. We go to Tools, we go to Board, and we select the Arduino UNO over here. Once selected, we're good to go. First of all, declare the library. The library we'll be using is servo.h. And if you see any errors over here, it could mean that the library is not installed in your Arduino. Go to Tools, go to Manage Libraries over here, and it takes a few seconds to open up. Search for Servo, and it's just going to be the first or the second one over here, and scroll up. Servo. This is the one we use. It already says installed for me, so I'm not going to install it again. Close it now. Moving on. Next, we need to create an instance of a servo object. I'm going to call it servo. You can call it anything you want. Next, we declare our pins and initialize them. So we declare an int variable, call it trigger pin. I'm just going to call it trig pin and set it to number 9. This one's going to be for the ultrasonic sensor. This is going to take the input. Next, it's going to be the echo pin. I'm going to set this to number 8, and this is for the servo motor. This is going to output to the servo motor. Next, we declare our 2 variables, distance and duration. So I'm going to declare duration as long, because this is going to be a decimal value, and I'm going to declare distance as int. Moving on to the setup now. So the setup only runs once, and first of all, we need to let the servo know that we'll be using port pin number 7 for the servo. And next, we make sure that the servo is in its initial position, which is 0 degrees. Thirdly, we add in a delay of 2 seconds, which is going to be 2000 milliseconds. Next, we need to set the trig pin as output and the echo pin as input. So we use the built-in function called pin mode. Tell what pin we are going to be using. Trig pin in this case, and we set it to output. Similarly for echo pin, set it to input. Alright, done with this step over here. Next, we need to start the serial communication and give it a baud time of 9600 milliseconds. So serial.begin 9600. Right, we're done with the setup over here, and we can exit the parentheses and start with the loop now. Again, what this loop does is it keeps actively searching for signals from the servo and the sensor. So first of all, we need to ensure that the servo, I think first of all we need to ensure that the trick pin is set to low. So this is how we do it: digital write, trick pin, set it to low, and we add in delay in microseconds for, I think 2 is what we need. Similarly, this again brings it back to the initial position. It's in case it's set too high. Now I'm just going to copy paste this and set it to high for time for 10 microseconds. Alright, now what we need here is that we need to ensure that the trick pin is set on high for 10 microseconds, and then we need to read the wave travel time in microseconds. So first of all, once you've set it to high, we need to ensure that we set it low as well. This time we do not need a delay. And for now we're done with the trick pin. We move on to the echo pin, and again digital write. Actually, let's set the duration first. So this is the formula that this is the standard formula that we use for duration. We divided by 2 because it's going to go and come back, hence the echo. And yeah, this is the formula we use for duration, and then we print the distance on the serial monitor. So to do that, to print the distance, go back to serial, print, let's format it in such a way print, and then ensure that we start on a new line and print the distance. Right? Hopefully this works well. Next we go on and write the conditional loop for if for the distance. So what we need now is we need to detect if an object is at a particular distance or not. So basically, I'm going to set this at distance 20. I'm going to set the distance as 25. So if distance is less than or equal to 25. By the way, this 25 is in centimeters. So if distance is less than 25, what do we want to do? We want to change the distance according to the ultrasonic sensor placement. We're going to keep distance as 25. You can set it to 30. You can set it to 50 as well. You can set it to even 10. It's all going to work. It's just going to judge how the distance between you and between the bin and the object. So if the distance is less than or equal to 25, the servo will be in its initial position, which is 0. Add in a delay. Maybe I think 5 seconds should be good. Not even 5 seconds. I think half a second should be good enough for here. We add the distance. If this distance is greater than 25, else servo.write. What angle did we want it to be? We want it to be 180 degrees. That's about it. And I believe we are done with our code. Now I believe I missed something over here. I am looking at this right now, and yeah, the part where we open and return the sound wave. So just before the distance, you need to return the travel time in microseconds. So duration is equal to pulse in Again, pulsing is a built-in function. It returns sound wave signals, and we set this to high. We're done with the code. Next, we'll move on to the actual physical setup. So now that we have actually uploaded the code to our Arduino board, this is how it should be. I'm going to use my laptop as a power supply right now. And if you followed along, if the code's correct, if everything's working correctly, if the cabling is correct, basically the idea over here is to make sure that the servo motor rotates 180 degrees once the sensor detects an object in front of it. So if I put my hand over here, the servo motor rotates 180 degrees. I remove my hand and it should go back to its initial position. So basically, that's how it's going to be. So here's our final product. There's our sensor over there in the front. The wiring has been done in such a way so that it does not come in the path of the garbage itself once I'm throwing it. The idea over here is that I'm going to place my hand in front of the sensor and I'm going to expect the lid to open. It's going to close once I remove my hand, but you can also play along with the code and program it to add in a delay of 5 seconds so that the lid actually stays open for 5 more seconds as well. I've placed the sensor over here in the front, but you can place it anywhere you like as long as it gets the job done. So again, close, open, close, close. Again, that's about it. Right guys, that's it from the workshop. We're done for today. I hope you learned something new. I hope you were able to follow along. I also hope that you see the future scope of this project. In a world affected by COVID-19, I believe technologies such as Arduino boards, servo motors, ultrasonic sensors, we can use these technologies that are easily available off the market to get ahead of the virus. We can use, through this project, we are trying to minimize the physical contact between humans and everyday objects, and I believe that great minds can put things like these to great use as well. Again, follow us on Instagram, follow us on our social media, Facebook, Twitter, and subscribe to our YouTube channel. Like this video as well. If you feel that this video helped you, try to share it with people as well. Maybe it will help them as well. Again, thank you for joining. Have an amazing day, have an amazing week, and keep building smart things.